Hey everybody, so in this video we're going to continue talking about the properties of logarithms. We're going to use the properties of logarithms to solve logarithmic equations, and then we'll talk about one additional property of logarithms that we could use. Okay, so here's our plan for solving logarithmic equations. Okay, we're going to use the log properties as our first step. To combine all log terms into a single logarithm. Okay, and then we're basically gonna just do the steps that we would normally do with a logarithmic equation. We're gonna isolate the log, change to exponential form, okay, finish solving normally, okay, whatever that means for that equation. And then again, the last thing that we need to do with log equations is check for extraneous solutions. Okay, and basically we are checking to make sure that we're not plugging in a negative number to a log, okay? So okay. All right, so let's look at some examples. Okay, so the first thing we're going to do is use our log properties to combine these two terms into a single log. Well, we know that when we have a sum of two logs, we can rewrite this as a product. So it's going to be log base 10 of x times 2, or 2x. Okay, and now we have a single log. We're going to isolate that log, which it's already isolated. Okay, and then we're going to change to exponential form. So the base of the log, which is 10, becomes the base of our exponent 3. Okay, and that's equal to 2x. Okay, so now this is no longer a log equation, and we can just go ahead and solve this normally. 10 cubed is 1,000. Divide both sides by 2, and we get x equals 500. Okay. All right, let's look at another example of when we need log properties to solve. Okay, so we're going to go ahead and combine these into a single log. So the subtraction makes a quotient inside of our log. Okay, and now we have a single log and it's isolated. So we're going to go ahead and change to exponential form. So the base of our log becomes the base of the exponent. Our exponent is 1. Okay, and then the other side of our question is x plus 5 over 2. Okay, now we know that 8 to the first power is 8. Okay, and if we want to get rid of this divided by 2, we're going to multiply both sides by 2. So we get 16 equals x plus 5, okay, or x equals 11. Okay, so I just want to really quickly show you that we are checking for extraneous solutions. So if you plug in 11 here, you get 11 plus 5, which is 16. And it is totally fine to plug in 16 to log because it is a positive number. Okay, we have the same thing here. We're plugging in 500 to log, which is fine because 500 is positive. Okay. All right. Now let's look at a couple of more complicated examples of solving. Okay. We're going to use exactly the same method. It's just that the method gets more complicated than that. Okay. Now again, this is subtraction, so we can combine this into a single quotient. So we get log base 3 of x minus 2 over x plus 1. Okay, equals 3. All right. Now we have a single log that's isolated on the left, so we're going to change to exponential form. We get 3 cubed equals x minus 2 over x plus 1. Okay, 3 cubed is 27. Okay. Now remember that in the last problem, when we wanted to get rid of the denominator, we just multiplied by it on both sides. And that's exactly what we're going to do here. We're going to multiply both sides by x plus 1. Okay, so here they'll cancel out and we'll just get x minus 2. Okay, and here we're going to distribute to get 27x plus 27. Okay, now we have a totally normal linear equation. We're going to subtract x from both sides. Okay, subtract 27 from both sides. And divide both sides by 26. Okay. Now, when we go to plug this in, right, we get negative 29 over 26. So let's look at what this would look like if you checked. Okay, so our original equation was log base 3 of x minus 2 minus log base 3 of x plus 1 equals 3. Okay, so if we plug in negative 29 over 26, okay, okay, so in the first term, we're going to get negative 81 over 26, okay, and in the second term, we're going to get negative 3 over 26, okay. Now, neither of these is good because we have a negative number inside the log. So this tells us that this is an extraneous solution, okay, and that our equation actually has no solutions. Okay. All right. So now you guys can see what an extraneous solution would look like. You go to plug it in, you're getting a negative inside the log, which we know you're not allowed to do. So there are no solutions to this equation. Okay. Let's look at one more solve. Okay. So we have a sum here, which we know turns into a product. Okay, and then I'm going to go ahead and distribute this out. Okay, Now that I have a single log isolated on one side, I'm going to change to exponential form. So remember, when there's no base shown, that base is 10. So I'll get 10 to the 1 power equals x squared plus 3x. And 10 to the 1 power is just 10. Okay. Now, because I have an x squared type of equation, I'm going to move everything to one side and try to factor. Okay, so I get x and x. So what multiplies to negative 10 and adds to 3? I think it should be plus 5 and minus 2. Okay, and I get my two solutions, x equals negative 5 and x equals 2. Okay, so let's check these, and remember we're looking at the original equation, okay, which was log of x plus 3 plus log of x equals 1. Okay, so if we check x equals negative 5, we're going to get log of negative 5 plus 3 plus log of negative 5. So this would be negative 2 plus log of negative 5. Okay, and we know that you can't have this because you can't plug in a negative number. So this is going to be extraneous. Okay, and then let's check x equals 2. Okay, so we get log of 5 plus log of 2. Okay, and that's totally fine. You can plug in these positive numbers. So this is our solution to this equation. Okay, all right. So that's really all there is to solving equations using log properties. You use the log properties to combine it into a single equation, and then you solve it the way we were solving other log equations, not forgetting about the possibility of extraneous solutions. Okay, so let's talk about the last log property, which is called the change of base formula. Okay. Now what the change of base formula allows you to do is change from one type of log, so log base b, into any other base that you want. Okay, now what this is mostly used for is to change from an arbitrary base into log base 10, or the type of log that we're actually going to talk about in the next section, so that you can evaluate it with your calculator. Okay, so let's see an example of that. Okay, now we know that this doesn't come out evenly, so we can't evaluate it by hand. And we know that there's no log base 2 on our calculator. So we're going to use a change of base formula, and we're going to change it to the log that is on our calculator, which is log base 10. So we're going to have log base 10 of 6 over log base 10 of 2. Okay, and this will allow us to plug it into our calculator. Okay. All right, so we would go ahead and do log of 6 divided by, that's not divided by, log of 2. Okay, and that would give us our approximate answer, 2.58. Okay. All right. This is really what people use the change of base formula for. There are a couple of other applications, but this is the main application, is being able to get an approximate answer from a calculator rather than your exact answer, which may have a different base that you can't evaluate with your calculator. Okay, I hope that makes sense, and I will see you guys soon.